Hello, in this video I will go over the answers for Exam 3 review. The first question is asking what is the area under the standard normal distribution to the right of negative 0.89? So we have negative 0.89 and we're trying to find this right area. We could look up the area in table E. So we have negative 0.8 and we go all the way until we're under the column for 0.9. That's 0.1867. But that is the left area. We want the right area, so we have to calculate 1 minus 0.1867, which is 0.8133, and that's the answer. To work this out in the calculator, we press second vers, go to number 2. Since we're going to the right, we type negative 0.89 for the lower value. The upper value is the maximum value the calculator can handle, 10 to the 99. Leave the mean as 0, standard deviation as 1. Select paste, select enter, and we get the same value, 0.8133. The second value is asking us to find the area between the z values 2.01 and 3.05. To do this, we have to look up both areas. Let's look up 3.05 in the table. So we have 3.0 go across to 5, 0.9989, and then we look up 2.01. Here's 2.0. 1.9778. We subtract the two values to get 0.0211. Okay, so to use the graphing calculator, we press second vars, select option 2, type in the lower value 2.01, upper value 3.05, select paste, hit enter, and we get the same value. 0.0211. For problem 3, we want to find the area to the left of 1.57. Using the table, we just look up the value 1.57, 0.9418. And if we use the calculator, we do the following. It's second vars number 2. Now we're going from left to right, so the lowest value is negative 10 to the 99th. The upper value is 1.57. Select paste, hit enter, 0.9418. So for problem 4, they give us the area between 0 and some unknown z value. That area is 0.3621. We have to find the missing z value. Now, the way that the table is structured, we need the entire area to the left of z. So we have to incorporate this area, which is 0.5, with the given area. We add them together to get an area of 0.8621. Next, we look up 0.8621 in the table to find the missing z value. So here we have to search for this area inside the table, and it's right here, 0.8621. Look to the left, 1.0, look up, 0.9. So the missing z value is 1.09. To use the calculator, we type second vars, we select inverse norm, number 3, we type in the total area, 0.8621. Select paste, enter. We round to 2 places, 1.09. We get the same result. Number 5 says the average amount of snow per season in Trafford is 44 inches. The standard deviation is 6 inches. find the probability that next year Trafford will receive at most 50 inches of snow. Assume the variable is normally distributed. So we have a normally shaped distribution. The average is 44. At most 50 means 50 or less. So we shade the area to the left of 50. Now we have to convert 50 to a z-value using the conversion formula. So it's 50 minus the mean of 44 divided by the standard deviation 6 to give us 1. And all we have to do is look up 1 in the table. So 1.0 is 0.8413. So that would be the answer. So if we use the calculator, we type second vars, option 2. Now in this notation, this is our negative 10 to the 99, written in scientific notation. So we just have to type in 1 and select paste, enter, 0.8413. Number 6 is a similar problem. It says the average amount of snow per season in Trafford is 44 inches. Standard deviation is 6 inches. Find the probability that next year Trafford will receive at least 53 inches of snow. We assume the variable is normally distributed. So it has a normally shaped distribution. The mean is 44, but we want the area to the right of 53. At least 53 means 53 or more. We next convert 53 to a z-value. So we have 53 minus the mean of 44 divided by standard deviation of 6. That's equal to 1.5. So remember, when we look up 1.5, it gives us the left area. To get the right area, we take 1 minus the given area. So let's look up 1.5. So 1.5 is 0.9332, and 1 minus 0.9332, 0.0668. That's the answer. You use the calculator, we type second vars, go to option 2. Our minimum value is 1.5. The upper value is the maximum value the calculator can handle, 10 to the 99. Paste, enter, 0.0668. Number 7 is asking the following. For an educational study, a volunteer must place in the top 35% on a test. If the mean for the population is 100 and the standard deviation is 15, find the cutoff score that would enable a volunteer to participate in the study. Assume the variable is normally distributed. So the distribution is normal with the mean of 100, and the cutoff score for now is labeled X. We have the upper 35% presented here. Now, according to the formula, we need the mean, the z-value, and the standard deviation. We're only missing the z-value. Now, to find the z-value, we need to find this left area. That's going to be 1 minus 0.35, which is 0.65. So this left area is 0.65. We can then look up the left area in our table. So we're looking for the area closest to 0.65, and it happens to be this area here, 0.6517. Look to the left, it's 0.3. Look up, 0.9. So the z-value is 0.39. We could also use the calculator to find the z-value. We type second vars, option 3. Remember, we're looking for this left area of 0.65. Select paste, enter, and if we round the two places, it's 0.39. Once we have the z-value, we can then calculate the cutoff score. So the mean is 100, plus the z-value is 0.39 times the standard deviation, 15. That gives us a value of 105.85, which we can round to 106. So the cutoff score is 106. All right, so now let's take a look at problem 8. It states the following. The average annual salary in Pennsylvania was $44,393 last year. Assume that salaries were normally distributed for a certain group of wage earners, and the standard deviation was $5,362. Find the probability that for a random sample of 25 individuals, the mean salary was less than $46,000. Now, since we're finding the probability of a mean, and the sample size is given, we must use the central limit theorem. So we draw the distribution of sample means. The mean of the distribution is 44,393, and we're looking for the area less than 46,000. So we have to use the central limit conversion formula for z. It's x bar, 46,000, minus mu, 44,393, divided by the standard deviation, 5,362, divided by the square root of 25. We'll type it in the calculator. I like to use parentheses. 46,000 minus 44,393, close the parentheses, divided by parentheses 5,362 divided by the square root of 25. We round to two places, so it rounds to 1.50. We look up the area, so 1.50 is 0.9332. And we could also just use the calculator. We type second bars, number 2. We have the lowest value already, so we just have to type 1.5 for the upper value. Select paste, enter, 0.9332. All right, so let's take a look at problem 9. It says a study of 40 bowlers showed that their average score was 186. The standard deviation of the population is 6. Find the 95% confidence interval of the mean score of all bowlers. Since the population standard deviation is given, we use z-values. So the formula we use is this confidence interval formula. We have all the information but the z-values. We can use table F to look up the z-value. To do so, we look for 95% and we go down to the z-values in the last column, 1.96. Then we plug everything into the formula. So x bar, the sample mean is 186. Z-value is 1.96. Population standard deviation is 6. Sample size is 40. And then we type this into our calculator and we get the results. The mean is between 184.1 and 187.9. To compute this on the calculator, we would have to type stat, go to test, go to option 7. We need to select stats. And then we enter the information. Standard deviation is 6. Sample mean is 186. Sample size is 40. The confidence level is typed in as a decimal, so 0.95. Select calculate. The left endpoint, 184.1. Right endpoint, 187.9. Let's look at number 10. It says the average weight of 40 randomly selected school buses was 4,150 pounds. Population standard deviation was 480 pounds. Find the 90% confidence interval of the true mean weight of the buses. So once again, we are given the population standard deviation. Thus, we are using z-values. We look up the z-value, 90%, go down to the z-value, 1.65. So we plug that information into the formula. X bar is 4,150. Z is 1.65. Standard deviation 480. N is 40. Let's type it in the calculator. So with the graphing calculator, I just type in 4,150 minus 1.65 times 480 divided by the square root of 40. Left endpoint is 4,024.8. Now you can retype in the right endpoint, or if you have this option, select the equation and change the minus to a plus. Hit enter. 4,275.2. Of course, another option, you press stat, go to test. You want number 7. Make sure you're on stats. Type in the information, 480 for sigma, 4,150 for the sample mean, N is 40, and then the confidence level is 0.9. Select calculate. We have our endpoints, 4,025.2. So we could see that the answers vary a bit because we're using a rounded value. So their answers is 4,025.2 for the left endpoint, 4,274.8 for the right endpoint. But those values would also be correct because these are more precise answers. Let's look at number 11. It says a sample of 25 tuna showed they swim an average of 8.6 miles per hour. The standard deviation for the sample was 1.6. Find the 90% confidence interval of the true mean. Now, sigma, the population standard deviation, is not given. Thus, we have to use t-values. So we need to compute degrees of freedom, n minus 1. Sample size is 20, so 20 minus 1 is 19. And we look up the t-value in our table. So in the table, we're looking for 90%. We go down to 19. The value is 1.729. And then we can plug that information into the calculator to get an answer for the left endpoint of 7.98. Right answer, 9.22. To enter this into the calculator, we press stat, go to test, but remember we're working with t-values. So we have to select option 8. Make sure we use stats. X bar is 8.6, S is 1.6, N is 20, and the confidence level is 0.9. Select calculate. Left endpoint 7.98, right endpoint rounds to 9.22. Number 12 is asking us to find a confidence interval for the true proportion. It states a poll of 600 frequent business travelers found that 360 of them found business travel stimulating. What is the 95% confidence interval for the true proportion? First step, we have to compute the sample proportion. That's 360 out of 600.6. Then we calculate the complement of the sample proportion. That's going to be Q hat, which is 1 minus P hat. 1 minus 0.6 is 0.4. 95%, we can look that up in the table to find the z-value, 1.96. we plug that information into our formula. So let's type it in the calculator. We have 0.6 minus 1.96 times the square root, and I just type everything inside the square root. So it's 0.6 times 0.4 divided by 600. Enter. We could round to 0.56. Select the original equation, and all we have to do to calculate the right side is change the minus to a plus. Enter. Round to 0.64. Number 13 says an educator desires to estimate within 0.03 the true proportion of high school students who study at least 1 hour each night. He wants to be 98% confident. What is the minimum sample size? Previously, he conducted a study and found that 60% of 250 students spent 1 hour a night studying. So for this problem, we're looking for the minimum sample size to estimate a proportion. The error, we can look at the word within. It's going to be the clue there to tell us that that is our error, 0.03. We go to our table to find the z value, 98%. The z value is 2.33. And of course, p hat is 0.6, so q hat has to be 1 minus 0.6, 0.4. Let's type that in the calculator. 0.6 times 0.4 times parentheses 2.33 divided by 0.03 quantity squared. That's going to give us 1,447.7, but we always round up to the next whole number. So the answer is 1,448. And finally, for the last problem, it states a psychologist is measuring the mean reaction time of mice to the ringing of a bell. How large a sample must be collected of measurements to ensure that the reaction time is within 0.01 seconds? Confidence level 99%. Population standard deviation 0.04. Here we're using the minimum sample size for a mean. That's the z value times sigma over the error, e, squared. So once again, we use within to determine e. That's a code word. E is 0.01. We look up our z value, so 99%. The z value is 2.58. Okay, so next we plug everything into the formula. The z value is 2.58. Standard deviation 0.04, error 0.01. Let's calculate this. Type the information into the calculator. Hit squared, enter, we get 106.5, which will round up to 107. Thank you for watching the video.